All right, so this is number 19 off the final exam review. It's a force problem. We have four forces that are acting on this boat, and it's a top view. It's like you're in a helicopter looking down on the top of this boat. So we have four forces. We got this 3,000 Newton force pulling. Here, let's draw an X and Y. So this way is X, this way is Y. So this 3,000 Newton force is perfectly in the X. This 2,000 Newton force, is perfectly, no, it's not. It's X and Y, right? It's pointing in the positive X and the positive Y simultaneously. Now look, what are we going to have to do to this 2,000 Newton force right here?
Get the X and Y.
X and Y components using trig. We're going to have to take this 2,000 Newton force, go X component, Y component with trig. Okay? The 1,500 is pointing in the negative X, right? So we have X. Oops, draw that better. X, Y. This 1,500 points negative X. And then this 1,000 Newton force points in the negative Y. So the first question, find the net X force on the boat. The net force in the X direction. How many forces are acting in the X direction? Three. We got one, the X component of the 2,000, and then three, the 1,500. All right, so let's add these up. So basically what we're going to do is we're going to sum forces X. So we have the 3,000, positive 3,000 newtons, plus, now how do we get the X component of this 2,000? That's going to be cosine 25 times 2,000. Should I explain that? Are you guys good? Because when you break this into components, there's the X component, there's the Y component. This angle in here is 25 degrees. So using trig, this X component is cosine 25 times 2,000. All right, then minus 1,500. Why did I make this guy minus? Because he points to the left. Let's just draw the sign conventions. Plus, minus, like that. Okay? All right. The answer to this, it comes out as 3,312.6 newtons. This is the total X force. Or in other words, the net force in the X direction. Just add up all the forces in the X direction. All right, part B. Find the net Y force on the boat. So how many forces are in the Y direction? 2. We have the Y component of the 2,000, which points up, and then we have the 1,000 that points down. So it looks like this. We have positive sine 25 times 2,000, okay, then minus the 1,000. Okay, this answer comes out negative. It comes out as negative 154.8 newtons. What does the negative mean? Negative Y direction. The total Y force is pointing that way. It's pointing down. Okay? All right. So any questions so far? Okay, part C. Find the overall net force. So here's what we just did. I'm going to shrink down what we've done so far. So here's what we found out so far. We know that the total X force points this way. And what is the total X force equal to? 3,312.6 newtons. Okay, we know what the total Y force is. It's 154.8 in the negative Y direction. It's that way. 154.8 newtons. Guys, notice, how did I put these vectors together? I put them together tip to tail, because what I'm trying to do is figure out what they are together. You know, the way you add vectors together is you put them tip to tail. The answer that we're looking for is the hypotenuse. So it's a vector question. This is the total net force. So how do we get the total net force? With Pythagorean theorem. So the total net force is going to be square root 3,312.6 squared plus 154.8 squared, and it comes out as 3,316.2. But that's only half the answer. What's the other half? The direction. You got to get this theta also. So theta is going to be tangent inverse. Opposite is 154.8. Adjacent is 3,312.6. So this theta comes out as 2.7 degrees. So the total answer is this: 3,316 newtons, 2.7 degrees below the positive x-axis. Hey man, what does below the positive x-axis mean? So here's our xy. What we have is this. Our total force points that way, where this angle here is 2.7 degrees. All right. Yo.
How does it go that way when it's supposed to go tip to tail?
Tip to tail.
Go like up left?
Well, the vectors that I added, see, the vectors that I added are this guy and this guy. And those guys are tip to tail. Right here, they're tip to tail. But the answer that we're looking for goes from the tail of the first to the tip of the last. Right? And it kind of makes sense, because look, if you think about it, what we found out is our x force points this way, our y force points that way. So what are those two going to give? It's going to give something like this at an angle. Okay. Part D. If the mass of the boat is 700 kilograms, what would be the acceleration? Well, do we have the total net force on the boat? Yeah. What does F net always equal? So for part D, you just go like this. Net force, F net, always equals MA. So A is going to be F net over M. And over here, we calculated the net force. The net force is 3,316.2. The mass was given as 700. So this gives us an acceleration of 4.7. And what direction would that be in? The acceleration is going to be in the same direction as the net force. So it's in the same direction. 2.7 degrees below positive x-axis. It's in the same, the acceleration is in the same, darn it. There we go. Acceleration's in the same direction as the net force. Okay, now, final question. What additional force on the boat would produce equilibrium? Okay, what does equilibrium mean? Like, I guess the key to the question is, what does equilibrium refer to? The word equilibrium means what? Acceleration is 0. And if your acceleration is 0, what else is going to be 0? What does F net equal? MA. If your A is 0, if you plug in right here, if A is 0, what's F net going to be? 0. So basically, what would create a 0 net force? It's pretty easy. Look, here's the boat. Here's the boat right here. What we figured out is that the total force on the boat is like this, right? We figured out that we have a net force equal to 3,316 newtons at an angle of 2.7 degrees. Basically, to create equilibrium, we need to kill this force. How do we kill that force? By having the same force in the other direction. We need another force going this way. And what should that force be equal to? 3,316 newtons at an angle of what? 2.7 degrees, but now that's above the what? Oh my goodness, there's an error here. Oh my. That should say what? The negative x-axis. Change that to negative x. We want that 2.7 degrees above the negative x-axis.